So here is drill number 1 for our Chapter 8 review. Ben accepts a job that will initially pay $8 per hour. Each month that Ben works, they will increase his hourly rate by 25 cents. And that's each month. If Ben works 60 hours each month, how much will Ben earn during his first year on the job? So we need to think about this. He initially gets paid $8 per hour. And usually when we see that word initially, we think starting amount. But they're not just giving him $8 right at the beginning. That's what he's actually going to earn the first month. But what we have to realize is that the $8 isn't what he earns the first month. It's $8 per hour the first month. So month 1, or the first month, which we call A sub 1, is going to be that $8 an hour, and it says he works 60 hours each month. So the first month, he earns $480. So we had to think through the fact that he's not just earning $8 the first month. He's earning $8 an hour, so he's earning $480 the first month. We also have to think about the fact that his hourly rate increasing by 25 cents doesn't mean he just earns an extra 25 cents every month. He earns an extra 25 cents every hour he works, which is 60 hours. So his increase each month is 25 cents times 60. Put that in your calculator, and you get $15. So this is an interesting problem because it's his rate that's changing, so you have to multiply it by the total hours. You don't want to say he earns $8 the first month and he gets an extra 25 cents the second month. It's $8 an hour, so 8 times 60, and it's 25 cents an hour, so it's 25 cents times 60. So my A sub 1, maybe I should use like a highlighter to show you this. My A sub 1 is $480, and my constant difference is $15. Because it's a constant difference, this is an arithmetic series. And since I do know the first month, I don't off the top of my head know the last month, I'm going to go ahead and use that second formula where it's 2 times the first term plus the constant difference times n minus 1. So I've got S sub that wants to know the first year on the job. That would be 12 months. So I have 12 divided by 2. 2 times the first month is 480. Plus the constant difference every month is another $15. And 12 minus 1, because it's n minus 1. 12 minus 1 is 11. So I'm going to go ahead and I'll start putting this into my calculator. Two times 480, I get 960. And 15 times 11, get 165. I'm thinking you guys can type the rest of that into the calculator and get your total answer. I'll tell you it's more than 6,000 and less than 7,000. All right, let's go on to number 2. If the first term in a geometric series is 3, and the fourth term is 15.1875, what is the 10th term? You know what, actually, since this is a review, I'm sorry, I'm kind of going back here. I'll go ahead and give you that answer. It's $6,750 because I do want you to be able to check and make sure that your answers are correct. All right, so I'm sorry. Number 2, if the first term in a geometric series is 3 and the fourth term is 15.1875, what is the 10th term? So we know the first term is 3. So, and it says geometric, so G sub 1 is 3. And the fourth term, so G sub 4, is 15.1875. And they tell me that it's geometric. Whenever it's geometric, I know then that it's going to be exponential. This is where I'm going to use my calculator, and I'm going to put these in as ordered pairs. This would be the ordered pair 1, 3. First term is 3. This would be the ordered pair 4, 15.1875. Fourth term is 15.1875. I'm going to go to Stat and Edit and enter that data. Right. So I'm going to put in 1 and 3. Sorry, I meant to put 1 and 4 because there's a first term and fourth term. Sorry. And I get 3 and 15.1875. And then I'm going to go to Stat and Calc, and because it's geometric, I'm going to choose Exponential Regression. So Stat and Calc. Exponential regression should be choice 0 right there. Enter twice. And I get the formula 1.74716029. I'm just going to write it all down. Times 1.7170711364 to the x power. Now notice the formula that it gives me is to the x, which means this is to the 0. This is the initial or starting amount. That's why it's not 3 to the x power. And that's why it is. So when I want to find the 10th term, I can simply put a 10 in there. So I'm going to put a 10 into this formula. To the 10th power. Let's go ahead and do that. 1.7471600929 times 1.7170711364. And I want to check and make sure I typed in my numbers correctly. Yep. To the 10th power. And I get 389.239014. Here's my final answer. Okay. All right, number 3. To the nearest hundredth. So we're going to round to the nearest hundredth. What is the value of, notice that's a summation, so we're going to, again, in this problem, we're going to use a geometric series. That means that it's a geometric series. And that formula is S sub n equals G sub 1 times 1 minus r to the n, all divided by 1 minus r. So it's S sub 18 equals, the first term is 4. 1 minus the common or constant ratio is 1.4 to the 18th. Notice these should always match. All divided by 1 minus 1.4. I'm going to go ahead and put this into my calculator. 4 times 1 minus, in parentheses, 1.4 to the 18th. That's going to be my numerator. And I divide by, in parentheses, 1 minus 1.4. 4,258.79, because it said round to the nearest tenth. So that 8 would bump that 8 to a 9. Okay, let's go to number 4. If the first term in an arithmetic sequence is negative 2, so a sub 1 is negative 2, and the 10th term is 61, a sub 10, 61. What is the 15th term? Okay, arithmetic is always linear, so I'm going to follow the same process that I did up in number 2, where I'm going to go to Stat and Edit and enter this data. So my ordered pairs would be 1, negative 2, and 10, 61. Let's go to Stat and Edit. Clear out those columns. So 1 and 10. And I have negative 2 and 61. Stat, Calc. So now I'm going to do Stat and Calc. And I'm going to choose linear regression, because that is arithmetic. Whenever we would simplify our arithmetic explicit formulas and we would distribute and simplify it, it always looked linear. So we're going to go with linear regression. And we get the formula y equals 7x minus 9. So if we're finding the 15th term, we're going to let x equal 15. So 7 times 15 minus 9, and I get 96. Okay. And that is my first drill.